All right, welcome back. We are Game 3001. That's Artificial Intelligence for Games in the winter 2022 semester at George Brown. And it's week 5, part 2, actually, of our broadcast. I'll be okay. And what we're doing this week is we're talking about pathfinding. And during lab or lecture, we talked about how to do different kinds of pathfinding. We said we talked about basic pathfinding. We talked about different kinds of graph structures and so on. We also talked about a guy named Dijkstra who kind of created something called Dijkstra's algorithm, as well as how do we process nodes in that algorithm and so on. We moved on to talk about what does that look like. It's kind of a very expansive kind of way of doing something where the way it's illustrated is it goes from, it kind of expands, that word expands. We talked about that from a data structure perspective. We'd probably want to use an adjacency list if we're going to do something with Dijkstra's algorithm, or even A star. We can use an adjacency list where you can use nodes as the positions, the next position that you're seeking. You're kind of expanding your list, to kind of find the closest or the shortest path from the start to the end goal. That's what we talked about. So this is definitely one division scheme using some kind of adjacency list with nodes. But what we're going to do today is we're going to use a grid. And what we want to think about is a different algorithm called A star, which is a little bit more efficient. And we talked about how there are two heuristics primarily that we're going to be concerned about. One of them is Euclidean distance, which we're going to handle. We're going to talk about heuristics next week. And then the other one is Manhattan distance. And what we're going to do today is we're going to create a grid of tiles that kind of looks like this, where I have a 40 by 40 tile. That's what I want. These 40 by 40 tiles are going to be basically drawn multiple places. I'm going to have a bunch of 40 by 40 tiles in a row, right? And I'm going to have some pieces of information in the tiles. I'm going to have a tile cost as well as a status. Is it visited, unvisited? Is it open, closed? Is it impassable? What type of tile it's going to be? And I'm going to use this for debugging information. So when you put together your quote unquote interesting map together, right? Then that is what we're going to use this to kind of see what the actual tile is. In fact, what we're doing is we're using a division scheme, that's what it's called, and we're creating something called smart tiles, where each tile knows the distance to the goal. So each tile knows how far it is, both from an actual distance. So like, let's say either using a heuristic like Euclidean distance or Manhattan distance, plus any additional tile cost to march across. Again, from a terrain value perspective, if we had one. So what is the goal of this lab we're doing today? We're going to clean up the placing, remove objects that were there before. We're going to create a tile class. We're going to make a grid of tiles, and we're going to be able to show and hide the grid using Imgui. And then finally, we're going to snap our starship, which is our starting position, and our target, which is our goal position, to the grid when we move things off. We're going to be doing a conversion. In order for us to do a this snapping idea, we need to do a conversion. We need to do a world to grid conversion. That's what we need to do. World to grid position conversion. So world position is where we're going to start. We always know the world position, that's in pixels. And then we need to have the grid position. That depends on depending on how big our grid is. And we're going to talk about how we're going to do that. Okay, so that is kind of our goal number 2. All right, so that is where we're going to start. And what I want to do with you now is start doing some of the stuff that Alex wanted us to do. So up on, again, up on Blackboard under Labs, for Lab 4, Alex, my partner in crime here, has put together a few things. A small version of the ship that you want to download. Also download these files, this navigation object CPP, the navigation object.h, and the neighbor tile.h and tile status.h. Those things there, these .h's, neighbor tile and tile status, they're enumerations. And the navigation object we're going to be talking about, which is something that we're going to add functionality to the agent class with. Okay, so that is this stuff. All right, awesome. So let's start with what we're going to do first. The first thing is let's download everything we need and then start cleaning stuff up. Okay. So what I've done is I've got a little sandbox that I'm working with. And here's my little sandbox, which is this one, right? And I've got some stuff in here that I'm going to use to copy paste into my project. I'm not going to download the default project from Alex. I already have a project from last week, but you can certainly start with Alex's project as a default if you didn't have a chance to submit your lab 3, and or if your lab 3 was not good, you're not happy with it, and you want to start from scratch, you can certainly do that. I'm going to go into my desktop where we have GBC GAME3001, and you guys are section 400. And under section 400, you can see that I have lab 1, lab 2, and lab 3. I'm just going to copy lab 3 and paste it. Okay, there we go. So this is where I'm going to start. And after I've done copying and pasting lab 3 and making a copy of it, let's rename this thing to lab 4, just like we've done before. Awesome. Let's refresh that, and that'll kind of put it into place. Awesome. And then what I want to do before I do anything else is get some of those files in place. Let's start off with NCL small. It's just the small version of our ship. So I'm going to copy it. I'm not going to pull it over, but copy, just in case you want to start over, so you don't have to download stuff from Blackboard again. And into assets, into textures, and paste. So now we have a small copy of our ship. Back up. And then I want to go into the SRC folder. The SRC folder has all of our files, as we talked about before. And what I want to do in the SRC folder is grab all of these files, right, the actual code files, and drag and copy them in. Okay, undo. I copied the NCL in there too. I meant copy this stuff and paste it in there. There we go. Let's make sure I just didn't mess up the assets textures, and should have the small ship in there too. Good. Awesome. So now I'm ready to start. I've got all my files that I downloaded from Blackboard, and I'm ready to go with the project we left off with last week. Okay, that's what I'm doing. So let's double click on my template.sln to start off Visual Studio. Right, and let's close all this funky stuff up because this is the stuff we had last day. Let's close all the tabs, right? And you may have to, if you're downloading from Alex, you may have to change this to x86 from x64. Hopefully you've already known how to do that. Let's kind of close all these things up. And let's start thinking about including some of those new files inside of our project, because we're going to just import those files in our project now. How do I do that? Well, I know I have 2 enumerations, right? So let's go to the enumerations, filter, right click, and I'm going to go to add existing item. Add existing item. Please do that. And when I go to add existing item, I'm going to go into the proper folder, into lab 4, into SRC, and look for those 2 items. There's 2. There's tile status and also neighbor. If you scroll up, there's something called neighbor tile. I want you to control left click so you can get both of those together. So neighbor tile and tile status, and then click add. So it adds those existing files into our project. Next, let's do it again, but let's do it inside of core. We have 2 more files. The other things that we had, which is our pathfinding files. Let's add a new or existing item, existing item. And if I scroll down, you can see that I have navigation object.h and not navigation object.cpp. Let's grab both of those 2 and add those in. There we go. Navigation object.h looks like this, and navigation object.cpp looks like this. Awesome. I'll talk about those in a second. Now, just to be preemptive, let's clean up our scene. So again, I'm going to go to scenes. I'm going to go to the play scene, and I'm going to start cleaning stuff up. We don't need our obstacles. Let's get rid of that. Okay, so that's gone. And I'm also going to remove the obstacle reference here. So no more obstacle reference. Bye-bye. Okay, so I've removed the obstacle from the placing in the .h file. Let's do the same thing in the CPP. So here we got a lot to remove. Let's just remove everything other than the SDL set render draw color and the draw function. Let's just kill all this stuff. Goodbye, that stuff. And the same thing goes with my update. Let's just kill everything in this if statement. Gone. We're not doing steering behaviors this week. We're doing pathfinding. So your draw and update function should now be clean and look like this. We have other places to clean up. You can see that I have errors in my scene. Let's go there. So snap to my start method. I want to remove any reference to my obstacle. That's gone. As well as some stuff in my Imgui. Let's go into my Imgui function and get rid of anything to do with obstacle, plus other stuff that makes no sense. Okay? Let's see what makes no sense. Well, first of all, let's rename this to lab4 debug properties. Save. Toggle debug we'll leave there for now. We're going to modify this later. Not required right now. Target position, that's good. I like that. But we don't care about the set target position for the spaceship. Goodbye, that one. See you later. That's target position. We don't care about toggle seek, speed, acceleration, turn rate, or whisker angle. We can get rid of all of this stuff and the reset button too. So all the rest of the stuff in Imgui, get rid of all that stuff. Clean up Imgui, please. So all you need in Imgui is did I take too much? Beautiful thing is I can always go back and put it back if I need to. Let's just make sure I grab this extra curly brace this time around and do it again. So yeah, so I don't need any of this spaceship stuff because we're going to be redoing it. Target is good, and I have my spaceship, but my spaceship is actually going to be my start. So that's going to be here. And this is going to be my target, which is going to be my goal. All right. I don't need the separator down here either. Let's get rid of that. Again, this is just cleanup. That's all I'm doing. Nothing special. And I'm just going to copy paste this target into the spaceship. And we're going to rename stuff, right, for Imgui. So instead of for my spaceship, instead of it's going to be the target, it's going to be the spaceship. Instead of position, we're going to call this the start position. So start position, okay? And I'm going to copy this start position in a number of places, here, here, and here. And we're going to change the target to the spaceship, M_P spaceship, for the position to start, here, here, and here. And now we're pretty good, but this has to say start position. And for my target properties, we're almost good. Just let's rename this to end. So refactor rename. We're going to call this the end or the goal position. This is where I want to send my spaceship. I want to get them to go to the goal or seek towards the goal, right? And this is all good, but we'll call this the goal position, right? So far, so good. Save. Nice, nice, nice. And that is my Imgui function right now. So I'm going to copy the Imgui function that I have right now as is. So you can paste this inside of your code just in case I'm faster than you. So copy this, and I'm going to go to the chat and paste it in there. That is the Imgui function. All right. Some other stuff that we need to do up here is Spaceship has a bunch of information. Let's get rid of everything except for instantiation. So no more heading or any of that stuff. Just the spaceship by itself, adding the spaceship in, okay? And the other thing is the spaceship is not right? We want to resize the spaceship so it's smaller. So let's go into the spaceship game object and change that too. So again, I'm going to go into the spaceship under the game objects, and we're going to change some stuff in here. Let's go to spaceship.h. And what I want is for spaceship.h now to use the new file I added in. I'm going to talk about this. I want to add functionality. So in navigation object.h, what we've added is a couple of new things. We've added a grid position. So I want each object that is a navigation object to know about where it is on the grid. It has to inherently know that that is the case, right? So instead of my display object or my navigation object, my spaceship inheriting from agent, I want my spaceship to inherit from navigation object, which we're going to have additional information, this grid position. We also have a simple getter and setter for grid position. That's all we're doing here with navigation object. So when I add navigation object as the parent of spaceship, it kind of takes the place of display object because navigation object is a display object anyway, right? So we're not losing any functionality, we're adding functionality. We're also making our spaceship class a little fatter because we're adding more stuff. Okay, let's do that. So spaceship.h, I want to change it from a public agent to a public navigation object. And because, actually, let's back up. Let's back up. I meant in my agent.h, I want to change it inheriting from a public display object to a public navigation object. I'll do that one more time. All right, and navigation object is not known, so we want to include it, and we want to remove display object. There we go. Okay, woohoo. So that means that all agents are navigation objects, every agent. And because my spaceship, is an agent, so too is it a navigation object. The other thing we want to change as a navigation object is my target. So right now my target.h, it's a display object, but we also want the target to know where it is on the grid. We want that the ability for us to convert from world position to grid position. So we want this to be a navigation object as well. And again, it's going to ask us to include it, and we can remove display object because navigation object is a display object. Okay, so all I've done is, right now, I've gone and changed my spaceship. It's still an agent, but I've changed agent to navigation object, and I've changed the target also to navigation object. Let's close this down and this down. And let's talk about navigation object just a little longer. So again, navigation object has two functions, set grid position and get grid position. And what this is great for is it can store the grid position as a vec2, x and y coordinates, in the grid. So that means that if I'm in the grid somewhere, I want to return the x and y position from a grid perspective back out, right? Not world space, which is pixels. So I want to go like pixels to grid and grid back to pixels. Okay. Cool. So that's what this navigation object.h does. Awesome. Okay, great. Other things I want to do in my spaceship, let's bring up my spaceship.cpp. We talked about this. Instead of using the large ncl.png file, which is like much larger, I want to use the ncl small.png. Okay. What is this? Well, if I want to look at the files, let's look at the files, open the folder in File Explorer. If I look at assets, textures, you can see that the small PNG, the small one, NCL small, is a 40 by 40 object, 40 by 40, right? And the large one is, well, 101 by 54. It's too big for the grid. So we want to make one that is sized for our grid. Our grid is going to be 40 by 40. I'm going to talk about that. Our target, our circle, is actually already 40 by 40, right? So that's pretty good. So that's why we're using the NCL small PNG instead of the regular one. Okay. Changes in our spaceship, right? The other thing that we want to do in our spaceship is I want to start thinking about things that I'm not going to do anymore. All right. So again, in my spaceship.cpp, where I am right now, right, then you can consider what we have to remove. So I'm not going to change any of this stuff. Who cares, right? It can set its speed and everything to its heart's content. I don't care about this stuff. What I do care about is that in the update function, it performs move. And move is bad. And the reason why move is bad is because move actually calls the seek method, right? That's what move does, calls the seek method. And seek uses look where you're going. And we're not doing steering behaviors. So I'm not going to erase these functions because they're pretty cool. Maybe we'll need them later. But I want to remove or comment out the move function from my update in my spaceship. And this way it won't move anywhere by itself. Save. And then what I can do is, after I've got these things set up, I've changed the parent of the spaceship to a navigation object, and I've changed the parent of the target to a navigation object as well. The ship was indirect because I changed the agent to a navigation object. Then that's great. But now let's take a look at my placing. Do I have any errors? Can I run it? Let's run it and see what happens. And this is our setup. This is like where we start, guys. Okay, so running is important because we want to make sure that it's okay. And then we'll put this up on GitHub. And I want you guys to stop me. I've had some weird connectivity issues today where from a connectivity, sometimes I lose you. Notice that I have my toggle debug. That doesn't do anything right now. And I can move my spaceship along still, no problem. Same thing with my target, but nothing else exists. That's what you should have right now starting off. Okay, let's put this up on GitHub. Again, what I'm going to do is I'm going to go open a repo and notice that I'm GAME3001. And you can see that there are labs, right? One of them is a for section 401, and you guys are section 400. That's you guys, right? So let's see if this is correct. I don't think it is. This is GAME3001. Did I not do? I think I did GitHub pages with you guys. I think I did. And let's do that. I always get confused because I think in the first class, the reason why we did Gitkraken was because, like I said, Alex and all that stuff, he prefers it and he made a point of it. So we can see that GAME3001 for section 400. That's you guys. And we can see that all this stuff has changed. So let's do things like, the first thing is added lab for project files. That's what we did. I'm going to commit to main. And I want to push this up when it's finished committing. Push. And now you should have everything ready to go for where we are with lab 4. Are you with me? Now there's no check mark. We're not on Zoom, and there are 12 of you here. How are we doing? Yeah, thumbs up is good as a reaction. You can use reactions too, right? Okay. Awesome. You guys are getting there. All right. Thank you for those thumbs up and those things. Awesome. Thank you. All right. So again, what I want you to think about, thanks, Trevor. What I want you guys to think about is what I've done. So I've started off fresh, and now I have to do more stuff. Let's go up on and see what we've done. So we've downloaded everything. Yes. We had changed that. We changed all references in the obstacle. We removed all Imgui functionality, right? We did that. And we did some of this too. We resized the ship. We snapped the ship to the grid. We haven't done that yet. But we're going to get more done now. So the next piece after we do all this is to finally add our tile class. Again, from a division scheme perspective, what we're going to do is we're going to add a grid of tiles. Each tile is going to be its own object. And we're going to make smart tiles, like we said. So for example, let's say this is the start and this is the goal. Then we can do is set up a tile, right, that is layered behind the goal or behind the start. We have another tile right here that is behind the Sorry, I don't have annotations. We have, it's behind the goal tile, and every thing on every grid, every tile on the grid is a smart tile that tells us the distance from each tile to the goal. And this will be updated dynamically. If I move the goal, so too will each of the tiles update eventually. That's going to happen next week. So for now, what we want to do is we want to modify our scene to include all of these things. Let's try it this way. All of these things. So every one of our scenes, or every one of our tiles, are going to be smart tiles, right? Like we said. And what we're going to do is we're going to have several smart tiles on the screen next to each other. All right, that's what we're going to make. So how do I do that? And well, I've got to start with a new class, right? So that's the first thing I'm going to do. So in my core, right, I'm going to add a new class. Let's close the play seed down for now. So we have nothing open. And I'm going to make a brand new tile class. So in my core filter, let's add a new item. And I'm going to march along, and it's going to be a .h. Make sure that it's not pointed in the template. Let's browse to the right place. Remember that we should look inside the SRC folder. Let's select that folder. So that is the place we want to look. And we start with a header, and that header will be the tile.h. And let's click add. So that goes in there. And now immediately let's add a new file, a new item, and we'll make the CPP file as well. We'll call this CPP file tile.cpp and also add it in the same spot. Let's add that in too. Awesome. So once we've added those two things in, tile.h and tile.cpp, right, let's start configuring. So we know what we want to do with the tiles. The first thing we want to do with the tile class is start, making our guard. So if not defined, and we're going to say tile, then we're going to define tile. Let's actually code it right. And then we're going to do an end if. And we're going to say that defined tile. Okay, that's kind of a simple thing we've done all the time. We're going to have a new class called tile, and tile is also going to inherit from a public navigation object. Why? Because tiles should know we should be able to convert tiles from world to grid space and from grid to world space. Okay, that's a navigation scheme or our division scheme, and we should be able to do both. Cool. I'm going to have public areas of our class as well as private areas of our class. Just to start off, what we need is some kind of constructor function, some kind of destructor function. We're also going to need some life cycle functions, as well as some getters and setters, also known as our accessors and mutators. Again, this is I believe it's a good quiz question. Mutators, right? And as well as some other functions potentially we might have later on. So for now, that's a good amount of space. I also should have some private instance members down here. That's where I put all this. This is how I've set up my class. And this should be something we've seen before. Okay, that's where we start. I'm going to go into my tile.cpp now and just make a reference to my tile.h just to make sure that everything is good. Okay. Now the add. Let's do it. So first, let's add in the tile constructor and the tile destructor. Lifecycle functions, we know what those are. Void, draw, right? We're going to override that. Avoid, update. We're going to override that. And avoid clean, which we haven't done much with. And we're going to override that. Okay, does that make sense? Then for our getters and setters, this is all new. We're going to come back to this in a second. What I want to talk about is the private instance members that we need to use. So here's the first one, a float m_cost. That's our first private instance. So we want to keep track of, like we said, if I look back here, we want to keep track of the cost of each of the tiles. The cost to travel to the goal, that's what that cost is. Okay, so cost, we want to do that. We also want to keep track of the tile status. So tile status is another class we're going to use. Let's take a look at that .h in a second. Tile status is we're going to call this m_status. And let's take a look at the tile status class. That's in enumerations, right? The following tile statuses are going to be, kind of be available to us that I've set up for you guys. Unvisited, open, closed, impassable, goal, and start. So just like we mentioned in our lecture, we're going to have different states, if you will, for each of the tiles. All right, so if I visited it as an example, and if I don't want it, it'll be part of the closed list. If I visited it and I want it, it'll be in the open list. If it hasn't been visited yet, it's not going to be something we've looked at. It's not going to be in any list at the beginning. Impassable tiles are also like mountains or things that you can't pass through. And the goal and the start tiles are things that we need. Okay, awesome. So that's what the tile status is, going back to that thing. So going back to tile then, that's it. We also want a couple of labels to display that, right? We want a label, right, which is going to be called the cost label. So that's going to display the cost. We also want another label that's going to display the status. Those are actual game objects that we're going to use. And what we're going to do is we're going to include the label class here. Okay. And finally, I want a pointer of an array, a pointer array of neighbor tiles. And what we want is for me to know the number of, and I want to do number of neighbor tiles, but I can't do number of neighbor tiles because I haven't included the neighbor tile.h. So what is neighbor tile.h? It's another enumeration. Let's take a look at neighbor tile.h and enums. We added that one in too. Neighbor tile.h, we're going to use a right winding kind of tile order where we start at the top tile, a tile above us, above the main tile. So again, if I was going to set up the tile, and if this was the main tile right here, this one, then this would be the top tile. This would be the right tile. This would be the bottom tile. This would be the left tile. And we would go in this order, in this direction. Okay, so top tile right, bottom left. That's kind of like the box model from web design, web development. That's kind of how we're doing it. So now that we've included it, we have this thing that is number of neighbor tiles. And if we wanted to have a division scheme where we also included the diagonals, which we do not include diagonals in our assignment 2, right? Then I could add additional ones here, and this number would be different. Remember, enumerations are integers, but the words help us because they're more intuitive than numbers. Numbers don't mean anything to us, but words, they mean stuff, right? So we can hide this, we can hide this. And down in here, where I'm declaring my array, I can say number of neighbor tiles. That's the number I'm going to put in there. Right now, it's 4. And so those are my instance variables, and I need getters and setters to get and set those things. So I'm going to say a tile pointer is going to be returned with my get neighbor tile. Get neighbor tile is going to take the neighbor tile, and it's going to give me a position, an integer position. What is the neighbor tile? Is it top, right, bottom, or left? And also set neighbor tile is also going to start with a neighbor tile position, but also I'm going to set a tile reference inside of that neighbor tile. So I'm going to, inside of the neighbors array, I'm going to set the tile that's relevant for the top or the right or the bottom or the left. So each tile is going to have an array of 4 neighbor tiles. All right, cool. And the next one is a float get tile cost, right? Which is going to return a const, the const function. Also set tile cost, if I want to set the tile cost, where it's a float cost. I also want to have a void add labels, because labels are going to be separate objects that I can add to the scene. And also I want to void set labels enabled, right, where I can pass in a Boolean state for this one. So I can enable the labels or disable the labels based on if I can, again, like I can enable or disable the labels based on if I'm looking at it from a debug view. All right, so that is my tile.h. I'm going to copy paste that into our chat, so you see that. I can't do it on YouTube, guys, but I can do it here on our chat for those people that are here. Okay, so that is my full tile.h file. Okay, so please use that and make your tile.h look like mine. Just going to check on YouTube if there's any questions. How do you deal with edge cases, like if I am on the edge of a map? What we do is for edge cases, we set the the neighbor tiles, the top and left and so on, top, left, or top, right, bottom, left, depending on which edge you're on, to null pointer, right? Which is, we're going to treat as, which we will treat as infinite distance and impassable, okay? So it's not going to be, they're still going to have stuff, but it's not going to be, it's not going to mean anything. It's going to, we're going to ignore those tiles is what we're going to do. All right, so that is the tile.h. What about the tile.cpp? Let's use ReSharper to generate those. So I'm going to just go and generate definitions by declarations, which is going to bring up this little dialog. And it's going to say, I'm going to make the constructor, destructor, the lifecycle functions, and the getters and setters. And let's do that now. And it's going to make them inside of my tile.h. So what does my tile.cpp look like? Well, first, let's set the cost to 0. Can you show where the button was? I'm not sure what you mean. What button? The generator. Oh, just a moment. That is, if you're using ReSharper, when you click here and you go there, it's going to actually it's going to ask you to generate declarations by definition by declarations. There's going to be another little option right here in the right next to the class. That's what it's going to do for us. All right, so thank you. So that's going to be there. And then what we want to do is we want to set width, and we want to set width to a config and tile size. Okay, what's config tile size? What is that? And how come I can do that here when I include tile.h? Well, because config is included somewhere else. Well, let's include it here anyway. So let's include config.h. What is config.h? Well, configuration is a configuration file, which we have some static constants here. So we have screen width, screen height, we have row number. So I've predetermined how many rows are going to be and how many columns and what the tile size is going to be. We're going to make a grid of 40 by 40, and I'll explain that in a second. So in my tile.cpp, I want to keep going. I want to set the height, right, to, again, a config tile size, the same size. So it's going to be a 40 by 40 tile, right? I want to set the my destructor to default. I don't want to do anything with my clean function, but I do want to draw stuff. So in my draw function, I'm going to use my utility function, my utility class to draw. So let's include my util class, include util.h. And my util.h allows me to do draw functions like we saw last week. So we're going to say util draw rect, right? Which is just allow us to draw a rectangle where we want to get the transform dot position, and we also want to use the get width and get height. So why are we going to do it this way? Well, because when we draw our tiles, we're not going to center them anymore as game objects. Tiles are going to be drawn from the top left corner. So if I draw the tile, I'm drawing it from here, and that is the position. The game object position is the top left corner of the screen, of the tile, right? So it's different than drawing a game object where we draw it in the middle. Tiles are drawn in the top left corner, from the top left corner down, like this. So that means that's why I can draw a rect like this. Update, I'm not going to do anything in the update right now, or the clean functions. In my get neighbor tile, I want to return a m_neighbors array and the position that I'm looking at. So that's going to be the position of the neighbor in the neighbors array. And I want to make this const. Okay. And set neighbor tile is kind of similar. m_, the other way around though, neighbors. And I want to look inside the position that I'm looking for, and I want to set the tile to that position. So now let's make that const. Cool. Get tile cost is, I'm just going to return m_cost. Okay. Set tile cost is the opposite. m_cost is equal to cost. Pretty simple. However, we have some additional things we can do there. When we set the tile cost, I want to update the labels, right? I want to update the tile label. And also I want to convert our string format to single precision. Why is that? Well, if I'm taking in a float, that can be a lot of digits. But remember, in our example, we only want to have one digit. I don't want to show more than that. Anything more, I mean, sure, we have more precision in memory, but on our label, we're only going to show one single digit precision, okay? Because it can fit that way better. So we're going to say that we're going to use a string stream for that. And we're going to use both the string stream class and the IO manip library. So let's include those two, string stream, as well as, that's a STL library, and IO manip, which is part of C++, nothing to do with us. And what I want to do down here is, so again, those two are string stream and IO manip. And I want to go down here and convert it, and I'm going to make a new stream object. So again, I'm going to do, let's make a new standard stream, right? And I'm going to call this a string stream, right? Which we're going to call stream. And the stream object, I'm going to pass into that a standard fixed number object, which is going to be set to single precision. So it's 1 decimal place. And I'm going to pass in the cost in there. So it's going to convert the cost, which is a full float, to a single precision number and store it in the stream. And then what I want to do is I want to convert it. I want to take a string. We're going to call it cost string. And it's going to be equal to the stream converted to a string. So I take the stream, convert it to a string, store it in the cost string, and then change the cost label's set text value to the cost string, which means whenever I set a new tile cost, then the string that's associated with the cost label is also going to change, and it's going to be a single digit precision object that I can store inside the tile. I can display in the tile like this. Okay? So that's the set tile cost function. And did I miss something? I think I missed some stuff. I didn't do tile status, and I didn't get and set tile status. So let's do those two as well. So that's something we missed. We got tile cost and labels, but we didn't use tile status. Let's add those in. And I noticed it because I was like, wait. We should have tile status too. So let's add those into the .h. So we'll say tile status is what we're going to return. We'll have something that says get tile status, right, which is going to be a const. And we're also going to have a setter, which is set tile status, right? And we're going to say tile status, right, which is the status we want to save. So what is this? Tile status. Remember that tile status? Well, that means that if I want to change the status from, let's say, unvisited to impassable, which is going to be I, we're going to set symbols to represent the tile status, then I need to be able to do that here in the with a setter, right? So we have two more to add, and I can do the same thing. So I know that, Thomas, you're asking, here's, again, how you do it. You go here, click on the light bulb, and you just generate definitions, Y declarations. You can do that anytime you add new functions. And then it'll pull up a little dialog box, and you can click finish. And depending on where you put that in the .h, it appears here on the .cpp, exactly where we want it. Cool. So now let's continue with the .cpp. So in the .cpp, in the get tile status, we're just going to return m_status. Nice. And in the set tile status, we're going to say that m_status is equal to the status, kind of value, again, which is a enumeration, number wise, integer wise, it's 0, 1, 2, 3 as an example, or 4, 5, whatever it's going to be. But we want to make this a const. And then, well, how do I set the tile status of the label? We want to convert the number into some kind of string. That's what I want to do, right? So we're going to use a switch case for that. So switch, and we're going to switch on m_status. And how does this look? Well, case unvisited, then we're going to do something. Case open, we're going to do something else. Case, where are these coming from? The enumeration. We're going to do something else. Close. Case impassable, we're going to do something else. These are all like a finite state machine in some ways. Case goal, we're going to learn about that later in the semester. And case start, right, we're going to do something else. So those are all the cases of status that we're going to get. And remember, what I've done here is I've just gone and marched along in the same order as the enumeration. So if I go look at tile status, again, one more time, you can see that that's how I march down. Unvisited, open, closed, and passable, they stand for numbers 0, 1, 2, 3, and so on. That's the status. So even though the status behind the scenes is a number, we can use these, words to make sure that it's intuitive for us as people. And we're going to say that, okay, now let's change the status label. So the status label, set text, and we're going to change the status label set text to equals for anything that is unvisited. And you can choose equals or dash or something that's simple. And let's make other symbols for the other ones. I'm just going to copy paste here just to speed up. And I'm going to use O for open. You can see what I'm doing here. C for closed. I'm going to use I for impassable. I'm going to use G for goal. And I'm going to use S for start. There it is. And now this is the way I can set my tile status. I can get my tile status and set it. Okay? And I'm doing this so that way I can update my labels. Again, going back to my labels, I can update these labels in my tile. Okay? Nice. Now the last two, and this is where all the work goes in. Well, we know what set labels enabled can do. That's easy. So we can say that if I set both labels to be enabled, it's m_status label, or the cost label. Let's do the cost label first. The cost label we can set enabled to state, whatever the state is. And we can do the same thing for the status label. Status label set enabled state. That's what we're saying here. And we can make this state that we're getting in const. All right, so that's the set labels enabled function. But what about the add labels? This is where all the fun happens when we print stuff out. And you're going to see something I'm going to put in here now that we're going to see over and over again. I want to set up something called an offset. And the offset is a GLM vec2, which is of size config tile size multiplied by 0.5 and config tile size, let's just do copy paste here, config tile size 0.5. What the heck is this? Why am I using an offset? Well, I want you to think about what I'm doing. If I start off with my tile, here's my tile object, and I want to draw this thing in the middle, I want to know what the middle is. So the offset is half the tile width this way and half the tile height this way to get to the middle of the tile. That's what I'm doing. That's the middle of the tile, 2020, right? And that's what the offset value is. It's 20, right, by 20. Okay, that offset is, you're going to see that over and over again. And maybe we can think about a way of including this so we don't include it here or everywhere else we're going to put it. All right, so now let's think about how we set up the cost label, and then we're going to set up the status label. How do I do that? So the cost label, let's instantiate one, m_cost label is equal to a new label object. We've done these before for your name and student ID and all that stuff. We've used these before. Let's set up 99.9 as a measuring distance, as well as Consolus as the font family, and 12 as the font height. Okay, and I want to, with my cost label, I want to get transform dot position, and I want to set this to get transform dot position plus my offset plus a GLM vec2 position, which is 0.0f, and minus about 6 pixels down, or up, I mean. So what does this mean? Well, we know the offset is in the middle, so that means like that's right here in the middle. And then I want to march up 6 pixels up where I'm going to position my label. So this label here on the top, I'm going to put it not in the middle, but I'm going to position it up about 6 pixels, something like that. That's what I'm doing with this thing, okay? Then what I'm going to do is I'm going to say, let's get my parent, and I want to add child m_cost label. So what the heck is parent? Well, remember that I can, because a tile is a display object as well, right? All display objects have a parent object, and normally the parent is the scene that they're connected to, right? We haven't set the parent yet, but we'll do that somewhere else. And then we want to m_cost label. Oh, and I want to set enabled by default to false. I don't want to show the cost label. It's only going to be shown in debug mode. Okay, now that I've done the cost label, let's copy paste and modify everything for the status label. So let's change this to status label, the first one. And literally, I'm going to do the exact same thing, just replace status label, cost label with status label. And this one, instead of being -6, which means up, I'm going to put this status, instead of being in the middle, it would be right here, to down a little bit lower, which is +6. So this will be +6 down. Okay, that's how it's going to appear. And that's what I'm thinking for my add labels. So the add labels function is just set the labels for my tile. Guys, that's it for my tile class, right? Let me copy all this, and I'll give it to you inside of your chat in Blackboard, Blackboard Collaborate Ultra. You should have the entire tile class now. Tileclass.cpp and tileclass.h. Just going to check our stuff on YouTube to make sure you're good. Yeah, it looks like you're okay. All right. Well, where are we? We've done this piece, and we need to do a commit. That took a lot of time, but we're about halfway, and this is where we should be, right? We're about 3 o'clock, about halfway, and we need to do the rest of the stuff. Let's do a commit. So again, I'm going to go up on GitHub Desktop, and I'm going to say added tile class. We haven't tested it yet, though. We will do that in a sec. And I'm going to push to my origin. Awesome. How do we test the tile class to make sure it works? Well, let's exit out of this. We don't need our config right now either. And let's open up our scene class, my start scene, or my play scene dot h. And to test it, I want to add the tile class in here. So I'm going to include the tile class, tile.h, okay? And I want to add a single tile for testing. So test tile. It's going to be tile pointer m_p tile. That's what I want. And what I want to do is with this tile pointer, I want to draw a tile on the screen. So let's do that in the playscene.cpp now. So in the playscene.cpp, I want to go with the playscene scope, and I'm going to jump to the start scene. So here's my start scene where I have my target and my spaceship being shown. Let's make a tile. Let's see how we can do this. So m_p tile then is equal to a new tile, right? We want to add child the tile. That's okay, but that doesn't really do anything. Let's position it so somewhere in the middle of the screen, like m_p tile. We're going to get transform dot position, and we're going to use a new GLM vec2 object to position it somewhere like halfway in the screen. So 400 by 300. Oh. Okay. And then not only am I going to do that, I'm going to position it, but I want to make sure I add all my labels. I want to do that. Add labels. You got to call that, or else the labels won't be added. But the labels won't know where to add themselves unless I configure the tile's parent. So tile set parent to this. This meaning the class, the scene class. So I set the parent to this. The tiles know where to go. We add the tile to the scene, and let's also show the labels. So we're going to, I want to be able to set labels enabled to true, so I can see the labels. Okay, that's a single tile. That's what I'm going to do with a single tile. All right, and let's test this to see if it kind of comes in at 400 and 300. Let's run and see if we have an error. Now, this idea, if we run properly, is what I'm going to do from every tile in the scene. Right? Hey, but we did something wrong. We did 99.9. It worked, but I copy-pasted. It's a copy-paste error. Let's fix that in the tile.cpp. That's why we're testing, guys. Right? So if we can't do one, we can't do any. Right? So in my game objects, tile dot, again, my tile class, and I put that, I think, inside of core. And my tile class is a game object. And let's move my tile class from my core to game objects like this. Just drag and drop. So in my tile.cpp then, where I set the label, I set the label to 9999. This should be, by beginning, it should start as equal or unvisited for now. Let's run it again to make sure that it works. And it should show that the status label is unvisited. Exactly what we wanted. Right. Confirmation check. Are you with me? Okay. Thank you, Trevor. How about the rest? The rest of you guys. Thomas, you're with me. How about everyone else? Stanislav, thank you. So the reason why I'm asking is because what about the rest of you guys? What about Braden and Benjamin and Sam and Tarif? How about you guys? Are you guys with me? Because if you're not, guys, this is the tile is the basis for everything you're doing with assignment 2, right? Thank you. Without the tile class, assignment 2 is undoable. Okay, at least with our division scheme that we've chosen. All right. All right, let's really do it now. So tile was a nice idea. This is cool. We'll keep this going here for now, right? And what I want to do is I want to comment it out, right? Because we're going to need something like that later on. Okay, so something like this is I'm going to use. But in my place scene, I don't just want to make a tile anymore. I want to add a bunch of more objects. Okay, a bunch of stuff in my place scene now. So what is that place scene going to look like? Well, let's define some stuff I need. So I need some pathfinding objects and functions. That's what I need. And let's start off with a standard vector of type tile pointer, which I'm going to call m_p grid. That's our grid that we're talking about. We're also going to make a Boolean, which is grid enabled, okay, which is a Boolean. And I'm also going to have a couple of functions, which is m_build grid. I want to build the grid somehow. I'm also going to m_set grid enabled, which is going to be of some kind of state. And I also want to read when the grid is enabled. So that's a kind of a getter and setter combination. Get grid, return a Boolean, sorry. A Boolean that is m_get grid enabled. Okay. And let's make the, just because we've done getter and then setter, we will move that around. So it's going to be getter first and then setter. All right, those are little private functions we're making. And then let's also add a couple of convenience functions, to convert world to grid space, is what we want to do, right? So how do we do that? We're going to have two of those functions. They're going to return the tile, a reference to the tile in the grid. And there's going to be one that is get tile. That's what it's going to be called. And it's going to take a column and a row. Okay. And the other one is also going to return the same thing. And it's also going to be named the same name. It's going to be an overload, but we can pass in as a convenience a vector2 object, which is the grid position. So I can either pass in the grid position if I know it, or I can pass in column row. So both ways give us some options. I don't need my debug Boolean anymore, but I'm not going to remove it right now because it's going to mess up my Imgui. Later on, we're going to come back and clean this up. All right, so that is what we need. So that is your new, the new part, this part right here, the new part of your playscene.h. I'm going to copy that into the chat. So please modify your playscene.h by adding those things. Now again, in order for you to have those things function, then you still need to have your tile.h included. Cool. In the playscene.cpp, now, what I want to do is I want to generate all those things. So I'm going to go to the top of the place scene, click on the light bulb. It's going to say generate definitions by declarations, and it's going to generate them, but they're going to go in the wrong spot. But let's generate them anyway. Let's click finish. It's going to put them at the bottom of my place scene. I don't want them here. Let's cut those out. In fact, what I want them is just underneath my start scene, my start function. Because there, what I can do is they're right and they're handy, right? I can go from here to there pretty quick. Place scene. So what I want to do now is I want to think about, all the stuff that I want to do with each of these functions. And sure, build grid is where all the fun happens. I'm going to call the build grid function at the top of my place scene. So before I do anything else, let's say before I add stuff, I'm going to call the build grid function. So m_build grid. That's what it's going to be called right here. I'm going to keep this commented out stuff and I'm going to use it in a second. I also want to return some of this stuff. I can do some of this stuff pretty good. So let's talk about the easy ones to knock off right now. Okay, so get grid enabled. That's pretty easy. Let's knock that one off. That is just going to return m_is grid enabled. That's what that's going to return. So that's easy to deal with. How about get tile and set tile, right? get tile and set grid enabled. What does set grid enabled look like? Well, that's a little bit more tricky. So we're going to say, when I set grid enabled, I want to say that m underscore is grid enabled is equal to state. That's the first thing I'm going to do. And we can make this const, right? And then after that, I want to say that, okay, if it's enabled, I want to draw the grid. So let's do a for loop, but we're going to do a for each loop. And we're going to say for each tile in the grid, that's what this means, for every tile in the grid, that's how you do it. Then we're going to say that tile set enabled to m underscore is grid enabled, okay? And how about the labels? Tile, I want to set labels enabled to m underscore is grid enabled. So what this does is it enables the tile object, and we'll say each tile object, and this enables the corresponding labels. That's what it does. The tile object and the labels, it enables them. And that's what m underscore set grid enabled does. When you enable it to true, either they enable them or disables them. Okay? Now get tile and get tile. There's the same name, but they do different things. Let's look at the first one. So the first one is going to return the tile in the grid, right? This one. Return the tile in the grid, and here's our grid scheme we're going to use. So the grid is actually going to be one big vector of, let's say, 300 tiles. We're going to talk about the division scheme in a second. And I'm going to go by row, start with row, multiplied by my config column number, and then adding the column after. So that's going to be the way I'm going to access the grid, right? So add this const and add this const. Now, because I'm using config, I probably should include it up here. And I haven't included it yet, so I'm going to include it down here. So I'm going to say include config.h. Okay, I probably don't need to because it's probably included somewhere else, but it's okay. All right, so that's what I do when I have a column and row where I want to get the tile in the grid by column and row, right? So this is converting, I'm converting the column and row position, and I'm getting back a tile. The tile actually has world position information on it because remember, it's just a game object. So I'm going to use this method to get back the world position. What's next? All right, well, I also want to do the same thing, but I want to convert my grid position vector into I want to kind of make them into column, which is my grid underscore position dot x, and auto row, which is my grid underscore position dot y. So this is the overload to give myself convenience. And then I was going to return m underscore p grid. I could use this thing and pass in, you know, this stuff into this thing. So I could just call this other function like a wrapper. So I can say something like m underscore get tile. I can return this, turn m underscore get tile, and I can pass in column row. So that would work too. Okay. So I'm this function, this version of get tile is calling this version. And let's make this grid position. Notice where it says, if I kind of hover in there, it says, it's asking me to make it const. Well, yeah, because I'm not doing anything with it. And these things, notice it says implicit conversion turns floating point into integer. Why? Because I need integers here and I'm getting floating point there. It's okay. I could cast them. I could statically cast them to integers. I could do that, right? So I could do a cast, right, where I want to convert it, static cast to int, right? But I'm not going to do that. All right, so that is my two convenience functions, and those are working. Okay, so that's pretty cool. How do I make my grid? What am I going to do? And how did I decide on 40 by 40 anyway? Well, let's think about this for a second. if my screen is 800 by 600, right? My screen is 800 pixels wide. Well, you can see that 800 is an even number, and so is 600. Well, I can divide both by 10. If I divide 800 by 10, I get 80, right? That means I have 10 tiles on, to the right, and I have 6 tiles down. That's pretty big. They're pretty large tiles, right? Because each tile is 80 pixels, 80 by 80. So I started with this and I said, okay, that works. Can I cut that in half? Can I say, let's divide 800, right? And I want to make it so that let's divide it by 40, right? So what if I did that? If I said 800 divided by, another common number is like 32. 32 works because I have 25 tiles to the right. And then what if I divide 600 by 32? You're going to see that that doesn't work. It becomes 18.75. It's an odd number, or sorry, it's a number that's not a whole number. We want whole numbers here. So that doesn't quite work. 32 would be nice if I had a floating world where I can scroll up and down. Who cares how big these are? I can choose a tile size of 32, right? But we're going to choose a tile size of 40 because if I divide 600 by 40, that works, right? I get 15 tiles. And if I divide 800 by 40, right, I also come up with an even number of 20 tiles. So I'm going to have a 20 tiles wide by 15 tiles high for our example. 20 by 15. So that's where I came up with these standard numbers, and I stored those numbers in the config class. The config class has a row number of 15, how many rows, and a column number of 20. If I multiply 20 by 15, I have 300 grid tiles. That's what I'm going to have, 300 grid tiles, okay? And that's what this is doing. I'm going to cycle through those 300 tiles, and I want to use 2 for loops, or a nested for loop. So I'm going to do a for I, and I'm going to start off with the row at the top, and I'm going to go as much as config row num. That's how many times I'm going to cycle through. And then inside of that for loop, I'm going to have another one. And I'm going to cycle for every column now. It's going to go to config column num. Okay? Now here's something you're going to see again. I want to make that auto, my const auto happen at the top for the offset. Remember that offset? Oh. Let's do a cost auto tile, the tile size. I want to have that. My tile size is just going to be an alias for config tile size, right? Instead of me saying config tile size every time, I'm just going to say tile size, okay? And then what I want to do is something that looks like this, what I already did. Let's copy this thing, or cut it out, and put it inside of here. The same thing that we did when we were testing out the tile, all right? I want to do something like this, right? But we're going to rename it, okay? So we're going to uncomment everything. And obviously there's no tile. We're going to make this a tile pointer, which we're going to call tile, okay? And I'm just going to replace m_p tile with tile. And let's talk about the stuff that we can do with it. So first of all, the position is wrong because we're going to make everything go on top of each other. Instead of this position, what I want to use is a GMM_vec2, a new vector that has the following setup. I'm going to start with a column, right? And the column is the x-axis multiplied by the tile size, right? So if my tile size was, my column number, remember my tile size is 40. So my column number starts off at 0. So 0 times 40, that's 0. So that's the first tile. And my second number is my row multiplied by my tile size. So that's what I'm going to add in. So that is the world position. Okay, so my world position, that is the world position of my actual tile, where it is. Okay. And then what I'm missing here is I want to add the tile to the grid position. So what I want to do is record the grid position. So I want to set the grid position of each tile to column and row. This is the way I can go from, I can go from, what the heck? There we go. I can go from world to grid position. So this is the grid position. I record both. Okay, so I record the world position and the transform and the grid position and the where I have it in the tile. This is part of the special class that we added, the navigation object class that we added into the agent. That's what we did here. Okay. And my parent is correct. I want to set my parent because if without setting my parent, that would be a bad thing. So we want to set my parent. Okay. And I also want to add labels, and I also want to set them disabled for now. So I want to set the entire tile disabled. And I also, by default, they're already disabled, so I don't have to do this. I'm going to say that once I add my labels, right, then I want to make my tile disabled. Set enabled to false. So my tile by default, you can't see it. Okay, it's there. And then finally, what I want to do at the bottom is I want to add this tile to the grid. Does that make sense? So it's the same thing. I'm just adding, instead of adding one tile to the screen, I'm adding 300 tiles to the grid. That's what I'm doing here. And that is your build grid function. Okay, cool. Let me try this out and let's see if I get a tile that's built for us. So I'm going to scroll up now to the start scene, and where I have my build grid function, I'm just going to make a breakpoint so I can build the tiles. Let's see if I don't get an error. And then once I build the tiles, I want to inspect the scene class and see what I've got. So let's run it and see what happens. So build grid is going to trigger. That's what's going to happen. And I want to see how many tiles I get. I don't see anything. No errors, thank God. And now when I go to this, that's the scene, I can go to the grid. You can see that I have 300 tiles. Look, size is 300, right? And I can scroll down and I can see that the cost is 0 by default. And the status is unvisited because I haven't set the cost right now or the status. It's just the default values. Notice also that the cost label has a pointer. And if I open one of these up, it gives me all that information, right? So I can look at the cost label details, the status label details, and I have a pointer, a neighbor array, and each one of the neighbors is set to null because we don't have any neighbors mapped out yet. That's next week. Okay. So that's what we do. So we know that the grid has been built properly. Awesome. Let's stop this. And let's put this up on GitHub. So I added a grid of tiles. That's what I did just now. All right. And I want to add it to GitHub because I want to make sure that we're all good. So again, I want to take away that breakpoint and I want to save the scene. And I want to go to GitHub desktop and put it up. So I'm going to say added grid of tiles. Okay, so commit to main, and then I push. Okay, are you with me? How are we doing? Are you getting it? Are you far away? Okay, thank you, Trevor. What about the rest of you guys? Are you getting it? How this looks? I'm going to put these functions from build grid all the way to all these functions here. I'm going to take all these functions here and just drop them into your chat. Okay, so you have all these functions I wrote, right? And you'll have everything that I have. There we go. That's all that stuff I just wrote. Okay, now the fun part. I want to draw it. I want to see all this stuff, right? So why are we not making a grid a game object? We could, but not yet. First, I want to test it. Stanislav, it's a good idea. I like your thinking, but I want to make it so that we're testing the grid functions here first, And then after I test the grid functions and they work, then I can extrapolate them and make my own grid object. Because remember, we're making a grid of tiles, and I want to do that here in the start scene or in the play scene. But yes, your idea is great because then we can use grids everywhere. I can make a grid object and add it, and then it adds everything. So let's go to the next piece, which is I want to be able to show the grid on the scene, right? And the way to do that is to modify my Imgui functions. I want to modify the Imgui functions now to do that. And let's go to that GUI function. And the first thing I'm going to add in, which is going to make you mad, and should make you mad because it makes me mad when I see it, is auto offset. I'm going to say that it's a GLM vec2 object, which is a config and tile size multiplied by 0.5 and a config tile size multiplied by 0.5. If you're not sick of this, I certainly am. This is bad. And you know what? I'm probably going to need the exact same thing. Guaranteed. This offset, I'm going to need in the start scene too. Let's go back in the start scene and put it there too, because I need it. Right here, like this. Okay, so I need it there, and I need it there, and I need it all kinds of places. Guys, this is it's screaming for you to put it somewhere. Where should I put it? Somewhere I can access it centrally, like the config class. That might be okay because it's already using config, and I can calculate an offset, config offset, which would be way easier than putting it in 10 places. We'll come back to that. All right, next. So yes, we're doing debug properties. Yes, we're going to toggle my debug, but instead of toggling my debug, let's call it toggle grid, and let's rename this thing to toggle grid. So just refactor, rename, and we'll call it toggle grid. We also put it inside of the tile class, Java. Remember? We had an offset for the tile class when we're drawing the labels. All right, so toggle grid is stuff is false. We're going to say toggle grid, and instead of m_b debug view, let's get rid of this. We're going to say that is m_is grid enabled, right, which is toggle grid. And then I'm going to call the m_set grid enabled to the m_is grid enabled, which is going to draw my tiles. So if I do this, just this piece right here, then I don't need in the placing.cpp.h, I don't need this m_b debug view anymore. That's gone. Okay. And no errors except for up here. You can see that the debug view is false. We can turn that away. We don't need that anymore, right? And with just that one thing in the Imgui function, which is this toggle grid function, we can be able to see the tiles. Let's see if I'm right. So run, and can I see the tiles? That's the most important thing. Or not. If I click on the grid, then bam, we see them. But take a look at poor NCL. It's completely not snapping to grid, right? And that's the next thing we need to do. Okay. For some reason, it doesn't draw a full square for my tiles. Okay. Again, for that part, because that's quite far back, you'd have to check your code with my code. I put it up on GitHub, remember? And for you guys to check, anytime you want to check my code with your code, if I'm going too fast or whatever, you can always go to github.com/George Brown College. And you can always look at the section that you're in, which is section 400. And if you look at lab 4, this link right here, then that is all of my stuff, you know, where you can always look at that anytime you want as we're going. Okay, so I'm going to also paste that in on YouTube for those people who need to look at my stuff while we're moving. Okay, because it's too far back. Like I can't troubleshoot with you right now. I can only show you what to do, and then you have to watch part of the video or look at this. You know, kind of compare your source files with my source files and see what the difference is. Okay, so on that, then let's continue. Let's go back. Because we want to draw, we've drawn the the grid. That's nice. And if I go to see what Alex has told us to do, let's go back to what Alex has told us to do. Alex says, okay, we made a tile, blah, blah, blah. We added a grid vector in placing. Yes, we did. We added code to build the render of the grid. Yes, we did that. We also committed that. Oh, we did, but we didn't really quite do that. So let's do that now. Let's put it up on GitHub. Did I put it up on GitHub? I did not. So let's do that now. We'll say added or display grid added controls to display grid, which is what we did. Commit to main and push. So we did that. Commit. Yay. Awesome. Next, we've already resized the ship. We want to start snapping the ship and the target to the grid. Let's do that. And we'll start with the placing the start function. Okay, the start function. So that's where we start. And in the start function, that's up here, right? Well, right now, the way we're adding like our ship and our target, it's like random places. I don't even know where that is, right? So instead of that, let's be more targeted, if you will. So for our target, we're going to say m_p target, and we're going to say get transform dot position, and we're going to say that we want to put it in a tile, let's say 1511, m_get tile. Let's get the tile that's at 1511, column row, okay? And if I have the tile, then I can get the transform. I can convert from a transform position, right? From a tile, this converts from tile space or from grid space to world space. That's what I'm doing, right? Plus my offset. Why? Because the object is going to be in the middle of the tile, not at the corner of the tile. That's what the offset's for. Middle of the tile. And I want to record that position on my ship. So on my target, m_p target. And we want to set grid position, just in case I want to go back the other way, which is 15 and 11. Okay. I want to do the same thing for the ship. And I want to just copy paste all of this instead of me doing it again. So copy paste. And let's change this stuff to spaceship. And I don't want to go 1511. That means I'll be on top of this one. Let's go somewhere else, like 1 and 3. So 1 and 3 is the top left corner. 1511 is somewhere at the bottom, right? And this would be 1 and 3. Okay? And I want to record that information in the spaceship class. Okay, let's see how this works, just this alone. And let's see if this works at all. Let's try it, and then I'll give you this code right now after we're done. So again, you can see that I moved the ship up there and the target down here. And if I turn on the grid, it's inside the grid, but it doesn't quite snap yet. Okay, doesn't quite snap yet. That's the controls we're going to add into Imgui to make that happen. Okay, that's step one. This is the code for our start scene. It's not going to change anytime soon. So here it is. For now, this is the code for the start function. All right, awesome. Let's move on to snapping everything when we move. Well, that's going to happen in the Imgui function. So the Imgui function has some little areas here where I want to move the start position and I want to move the goal position. That needs to change the way we're doing that. And I need to use this offset again, right? So how does this work? So start position is the spaceship, but instead of it being the actual position in world space, I want to get the grid position that I set. So instead of get transform position, let's use grid positions now when I move stuff. So I'm going to say get grid position dot x. Okay, get grid position, get grid position. Get grid position for here for the goal too, because we're going to change that to grid position now. Get grid position. Awesome. Grid position is going to return a vec2 object that has x and y values that are the grid position. And we're going to store them here in a float array, start position and goal position. Awesome. So the slider 2 now, it goes from it uses the starter position, go from 0, but not to the 800, but rather I want to go to grid space. So now it's going to use config, and it's going to be column number -1. And the same thing over here, config column number -1 is what this is going to be. So the same number. But that's too big. The slider float is too big for the row. If I have column number, that I can go way off into oblivion on the row. Rows is only 15 rows, but there's 20 columns. It's not equivalent. So I need to make a check for this. So what I want to do is, if my start position, if the start position 1, so that's the y-axis, if it's greater than my config row number, right, -1, because we're adjusting for the index, then what I want is my start position on the x-axis to be equal to the row number. It's not going to allow me to go beyond this value. That's what this is. So this is kind of a check. So constrain the object within the row. The row max row, within max rows. Right, that's what it does. So it doesn't allow me to go beyond the maximum row. And I want to do the same thing, right, with the target, right? So let's do the same thing with the target. Let's just make sure that it says target or goal position instead of start position. I'm just renaming, I'm just copy pasting to make it quicker. Nice. Finally, this is not sufficient. M_P get transform position, right? That's okay. But now instead of doing this, I want to use M_get tile. Remember, I want to convert from the grid position to the world position. That's what this M_get tile does, right? And when I pass in the start number and the X and Y position, right? And then once I have this, I want to use the get transform dot position, and I want to add in a offset plus the offset at the end. Remember, because that's kind of what we did in the start function. I want to do the same thing, the same exact thing here, right? For my target, we'll just rename the start positions. So I'll grab all this and put it here in my target. And so this will be, instead of start position, will be goal position. Just copy that in. And now this will be the same thing. And this converts from grid space to world space. Okay, and saves it inside of my actual position, because my target is a game object. All right, so I need to actually be positioned somewhere in a pixel, right? Okay, so that's what this does. And then I want to save that. I want to record that in my navigation object, which is my spaceship. I want to record the grid position so I know what it is. I can always get it back. And I want to use my start position, this stuff right here, and I want to put that in there. So I'm going to set wherever I'm at, I want to set it, and I want to record it. So this records the grid position. This converts, right? Converts grid space to world space, right? So I grab this part right here, copy it, and we'll just rename it for the target. So instead of spaceship, it's target. And what this does is it nicely snaps our target to grid, snaps our spaceship to grid. Why? Because I'm moving exactly in the middle of each of the grids, each of the tiles. I'm moving from one tile to the other tile, maximum number of tiles wide, right? And I'm hopping there because I'm converting my grid position, whatever my grid position is currently. And I'm doing that when I move it, I convert from grid position to world position. So I position it onto a pixel somewhere, right? But I record the grid position. So when I come back here, I can get that position, right? And I can use that position so that inside of the float, the slider float. It might be confusing, but at the end of the day, all I'm doing is I'm converting from one type of space to another. Okay, and I need to do that because I have two different division schemes, right? My first and main division scheme always, when I'm coding in 2D, is pixels. I'm dividing up my screen into pixels, right? And that's world space. And then I have my other custom division scheme, which is grid space. Do we also switch the start position to goal position? No. Did I make a mistake? For the MP target in line 180. 180, MP target. Oh, yes. Thank you. That's a mistake. That's a copy paste error is what we like to call it. All right, let's do that. Let's run this thing and see what happens. Does it work? Is it bad? Is it broken? Like, what's going on? So we have everything in place, but now when we move stuff, if I toggle the grid, take a look. If I hop around, now it's limited. I can't go in between the grid space. It's in the exact grid position. And guys, this is a great way to start for next day. Even if I want to go beyond there, I can't. Look, I can't go I can't go less than or greater than that, right? I can't go less than or greater than that either, right? So I can't do that. So it can't wrap. Look, okay, that's all it does. Same thing with this. So I can be exactly where I want to. I can put them on top of each other if I want, right now, because there's no limitation on doing that, but that's all it does. By the way, before we go, and before I save this, I want you to consider what we've done here. We've subdivided our screen into 300 tiles. Now this has a lot of power because I have information now, just now, even the way it is, on what object is in that tile, the grid tile, right? This is another way of doing collision detection, if you think about it, right? I'm not even going to check these tiles right here. The only time I'm going to check if I'm colliding is if I'm either close or right in there, right? That's the only way I'm going to collide, right? So if I divide my entire screen into grids, 300 tiles, then I'm going to instantly know when I'm going to collide, instantly, right? Because I have inherent knowledge of where my object is in the grid. If there's two objects in the same grid space, it's colliding 100%. So that's another thing we can do with a division scheme like this. Okay, let's exit. And let's put this up on GitHub. And let's see if we met everything. So we snapped objects to grid. Okay. And let's put this up on GitHub. And let's see if we met all of Alex's requirements, because I want him always check to see if we did. So we've snapped the ship to target. Make sure to set the parent of the target to navigation object. We did that. Also make sure the agent is a navigation object. We did that. We committed. We did that. We added elements to change the grid positions for ship and target, and add toggle to show the grid. We did that. We committed that. And for you guys, you got nothing extra to do for this part, because next week we're going to have more, because this is a two-part lab. If you look up on Blackboard, you can see that lab 4 is actually due week 6, Sunday, February 20th. It's worth 8% of your final grade, this lab, 4% per part. And this is the lab 4 part 1 steps. And there's also lab 4 part 1 report. So please take a look at this report. That's what's required. But remember, this is not due. The whole thing is due next week. All right, any questions before we go for the day? And I'm happy that we finished on time. So remember what we did. We made our own tile as a review. We made our own tile system. right? Our own tile object, and we made a grid of these tiles. That's what we did. Can I show Untitled rect? Yes, in the tile CPP. Sure I can. Let's do it. So in the tile CPP, that's inside of game objects, tile CPP, and that's it. Anyone else? I told you, there's nothing different, right? So something is up with your stuff. I would challenge you to download my code after we're done. Download my code from GitHub, all right? And run it and see what you get. But do that. Because I'm telling you, there's something that is missing from your side. All right, guys, that's it for me today. Thank you so much. I'm going to stop recording on YouTube in a second. One thing to note just before we get going, right, as an example, remember what's due, right? Remember that this is important stuff. You need to continue to work every week on your lab, right? If you don't do the lab part with me every week and with Alex, as an example, or with Alex, then what's going to end up happening is you're going to fall behind and you won't be valuable to your partner for assignment 2. It just won't happen. You won't know enough to make this work. I'm sorry, sir. You were asking if people were with you, and I'm just lagging a bit behind following along on YouTube. Yeah, I'm going to finish now on YouTube, Sam. Do you need support or report for one part? Not right now, Stanislav. It's going to be due next week. So if you want to, you can already do a submission, but the whole thing is due next week. Okay. So if you've already finished first part, check through it, and you can certainly submit it on your own, and then you can submit the second part next week. No problem. Okay, that's it for me, guys. I'm going to stop recording on YouTube, and then we're going to end for the day. Thank you. And that's it for me today.